Introduction. Last November, the moment finally arrived and WHG-64 became the first star outside the Milky Way to be captured on camera by the Very Large Telescope. But this was no ordinary stellar object. It was a colossal behemoth many times larger than our Sun and one of the largest stars known to exist in the entire universe. However, closer examination has revealed some astonishing details. WHG-64 is dying and about to explode in a violent explosion. When that happens, the red hypergiant will probably give us the next supernova visible from Earth. But what dramatic changes indicate that the brutal death of this star is imminent? And how did the experts manage to get a close-up image of WG-64 even though it's 160,000 light-years away from us? Stay tuned until the end and see for yourself what exciting details the observation of this stellar giant has revealed. In our perception, our parent star is often the cosmic measure of all things. And that's not really surprising because after all, the Sun has an incredible diameter of almost 1.44 million kilometers, making it so large that our Earth could fit inside it about 1.3 million times. But that's not all. Our source of warmth and life also contains 99.86% of the total mass of the solar system. But when we compare the Sun with the other structures in the cosmos, and this is the astonishing thing, we realize that we do not orbit an exceptionally large central star at all, but merely a medium-sized yellow dwarf, which is considered an average star of the main sequence. Away from the stellar average, however, there are, of course, celestial bodies that reach almost ridiculously large dimensions, and compared to which our Sun is nothing more than a puny glowing pinhead. And WHG-64 is one of them. While it sits enthroned in the large melaninic cloud some 160,000 light-years away from us, it outstrips the Sun by a factor of 16 to 22 in terms of mass alone. Briefly to put this into context, contrary to its name, the large melanic cloud is not a cosmic cloud formation, but a satellite galaxy of the Milky Way, which is the fourth largest member of the larger local group. And although the galaxy contains only 5% of the number of stars in our galactic home, it's home to a colossal giant that is around 1,700 times larger than our Sun. At the same time, WHG-64 shines 280,000 times brighter than our parent star. And as mentioned at the beginning, it's even one of the largest known stars in the entire universe. However, it's also one of those celestial bodies that have begun the final chapter of their cosmic life. After all, studies of the red hypergiant have shown that it's already ejecting large amounts of gas and dust from its bloated envelope, creating a dust ring with a diameter of about 30,000 astronomical units. And remember, a single astronomical unit is equal to the average distance between the Sun and Earth, which is approximately 150 million kilometers. And now we actually have the exciting opportunity to take a detailed look at the aging star and its bizarre surroundings, not in a simulation or computer animation, but in the form of a direct close-up. WHG-64, the first image of an extragalactic star. In step with technological progress, increasingly powerful telescopes have enabled astronomers to image some stars and even exoplanets in detail. This meant that these alien celestial bodies were no longer visible as blurry points of light. Unfortunately, however, this was generally only true for nearby and large objects such as Polaris and Betelgeuse. Scientists were simply unable to capture stars outside the Milky Way with a camera. But excitingly, this is now a thing of the past. We owe this to the team led by Kiichi Onaka from the Andre Bo University in Chile. More specifically, the experts used the gravity instrument on the Very Large Telescope, which utilized data in the near and mid-infrared range. And as we can see, the portrait image not only shows WHG-64 in the center, but also confirms that the star has long been shrouded in dense dust and is accompanied by a surrounding ring of dust. In other words, the image leaves no doubt that the giant star has indeed reached the final phase of its life cycle. But that's not all. The image also reveals that the cocoon of dust and gas actually has a completely different shape than previously thought. More precisely, we are dealing here with an egg-shaped structure that tightly envelops the celestial body. However, the reason for this elongated shape has not yet been conclusively clarified. It's conceivable that WG-64 ejected the material of its shell unevenly during a major eruption. Alternatively, the shape could also be due to the influence of a previously undiscovered companion star. True to the motto, one stellar surprise rarely comes alone, the researchers also recorded another unexpected circumstance. The scientists have discovered that the star has undergone a significant change. Although its near-infrared radiation has increased significantly over the last 25 years or so, it has remained stable in the mid-infrared range. The astronomers explained that this change in the shape of the spectrum can be explained by the formation of hot dust near the star. The material ejected by WG64 first condenses into transparent grains of aluminum oxide and magnesium silicates. Iron-containing silicates then deposit on these grains, absorbing more radiation, which increases the near-infrared radiation produced by the heated dust, while the star itself becomes darker invisible light. When will G64 explode? Co-author Jocko Vanlin from Kiel University in the UK summarizes the situation of the star as follows. Quote, WHG64 is one of the most extreme of its kind, and any drastic change could bring it closer to an explosive end. However, this naturally raises the question of when exactly this explosive end will take place and why massive stars leave the cosmic stage in a violent supernova in the first place. Well, basically WG64 is at a stage where the hydrogen, the star's original fuel, has long since been consumed. The fusion process inside has already shifted to elements such as helium, carbon, and oxygen, which are burned one after the other in increasingly hotter layers of the celestial body. The final step in this chain is the formation of an iron core. But iron also marks an important boundary. It can no longer be fused into heavier elements without consuming energy. And as soon as enough iron has accumulated in the core, the balance between the inward gravitational pressure and the outward radiation pressure is disrupted. The moment the iron core exceeds a critical mass, it collapses under its own weight in a fraction of a second, causing temperatures and pressure to rise to unimaginable levels. And the bottom line is that this sudden collapse leads to a massive explosion. The outer layers of the star are hurled into space with enormous force, and the Type II supernova is complete. As you can imagine, given the size of WG64, this will not be a faint glow, but a stellar death that will shine as brightly as a full-grown galaxy for a short time and will even be visible across the vast distance to the Large Magellanic Cloud. In fact, it's even possible that we will be able to marvel at the final act of this stellar giant with the naked eye. Although the word "we" is relative in this case. Although astronomers cannot predict the exact time of the supernova, they suspect that it will occur within the next 1,000 to 10,000 years. And while it's rather unlikely that we will notice anything at that point, this immense period of time is nothing more than a fleeting blink of an eye on a cosmic scale. For future researchers, however, the significance of the supernova will lie not only in the actual explosion, but also in its consequences. Such cosmic events catapult large quantities of heavy elements into space, including iron, nickel, gold, and even uranium. These substances are essential for the formation of new stars and planets, and thus also for life as we know it. This becomes even clearer when we consider that our Sun is a so-called population 1 star, which means that it consists of enriched material, or in other words gas and dust, that has passed through at least one generation of earlier stars and supernovae. Our Earth too, with all its metals, minerals, and biological elements, is the product of this stellar recycling. Apart from that, a supernova is also a kind of test laboratory for astrophysics. It allows researchers to test theories about core collapse, neutrino emissions, shock waves, dust formation, and even the birth of neutron stars or black holes. The bottom line is that WG64 will not disappear completely from the cosmic stage. Whether it will ultimately turn into a neutron star or a stellar black hole depends on the exact mass of the core after the collapse. If the remaining core is heavy enough, the collapse will not end with a neutron star, but will result in the formation of a gravitational monster. In the usual manner, however, this will remain invisible and will only be recognizable by the glowing shell of gas and dust that was thrown into space by the explosion. And now you're welcome to click on the subscribe button. Simply press the thumbs up and subscribe to never miss a new video from us again. We'll see you soon.